Good day, good afternoon, and good evening from the Radiant Professionals Alliance. Welcome to Hydronics Talk, a presentation of the Radiant Professionals Alliance. I am Mark Etherton. I am the current Executive Director of the RPA. I've been a member for the last 20 years. I'm a contributing editor to Contractor Magazine. I've been educating for around 39 years, give or take. I'm a former expert witness and still a current licensed master plumber in the state of Colorado. Quickly want to go over some rules of the road here. Forgot to transfer the ball of power back to myself so the screen's not progressing. Glad I had my backup screen here. Rules of the road. If you wouldn't mind, please use headphones with a boom mic if at all possible to avoid any feedback if we happen to enable your mic so that you can ask questions. If you have any questions, type them into the Q&A question box, and I will see those. And as soon as I see that, I will stop our guest and present him with your question so that we don't get overwhelmed with questions at the end. Any questions regarding the presentation may be responded to after the presentation, or if you have something that is not topically related that you would like to talk about, feel free to submit a question and we will address it at the end with all of our experts. I would like to thank everybody for attending. Here's a little bit of history and information on me. I'm a big fan of alternative radiant heating systems. This is a radiant wall panel system that we constructed for the National Renewables Energy Laboratory project, which was actually set up as for the Habitat for Humanity, and it is still working to this date. It's been in for 20 years. The consumer is very comfortable with it, and the project has actually shown some of the greatest energy savings of any of the Habitat for Humanity houses that are on the market. Here's a rough installation of a radiant ceiling heating system that I put into my own personal residence. Nothing better than living with radiant ceilings yourself so that you can relate that comfort to the consumers on a first-name basis as opposed to saying, I've heard that. And I love this system. It's quite comfortable. The only time that you can really feel it producing warmth from the ceiling is when it's at design condition outside. And at that point in time, it is actually a very welcome comfort condition. Here's the one of two commercials that you will see during this presentation. We ask that you please join the Radiant Professionals Alliance if you're not already a current member. We are an organization of the members, by the members, for the members, with all of the members benefiting from our efforts. And our intent is to prove something that most of the people that are in attendance here have known for a long time, that hydronics is the most efficient method of transferring heat or cooling from point A to point B or point B to point A, and get the world onto our bandwagon so that we can start doing what we need to do. Give you a little information about the talk show. This is a once-a-month show. We have a guest coming in to be interviewed and have us give us their presentation on the products and services that they provide. Open Q&A session following the interview that doesn't have to pertain to the actual presentation. So if you have something that you would like to get some opinions from our participants on, by all means, feel free to raise a hand, send me a note. I'll enable your mic, and we'll do our best to address your question. These programs are archived for our members only for viewing at a later date, and you gain access through the members only section of the Radiant Professionals Alliance website. And these shows are meant to be fun, educational, entertaining, and of course, fun. And if you have a person that you think would be a good person to be interviewed on this show, submit the guest interviewee to mark.etherton@radiantpros.org, and I will get them into the schedule. Quickly, have some hydronic news that you can use. The RPA's University Spring Course offerings are currently up on the website at heatspring.com. Please check that out. There's a whole lot of really good classes up there by a lot of different people. Siegenthaler's up there, Bean's up there. I'll be up there eventually as soon as I get my class put together. We have Ray Wolfarth, we've got Dave Yates, Vaughn Woodruff. We've got a really good bunch of people that are coming in to teach for us, and share their expertise and years of experience with people that are interested in learning. The Canadian Institute of Plumbing and Heating is currently holding their SciFex program, which is in Metro Toronto. So for any of our Canadian listeners that happen to be in that area, I would strongly advise that you drop in and visit them. I've been to a couple of those shows up there, and it is really great. It's primarily a hydronics-based show. They are a hydronics-based organization. And if you get a chance, definitely drop in there and say hello to Michael. Here's our real quick image disclaimer. The graphics and illustrations used in this webinar are presented for educational purposes only. RPAI-ATMO does not endorse nor recommend the vendor, product depicted, nor any vendor or products. RPAI-ATMO makes no representations, warranties, or guarantees as to and assumes no responsibility for the products depicted, and RPAI-ATMO expressly disclaims all liability for any damages of any kind arising out of the use or performance of the vendor's products or services depicted. There is Mr. Springer. Mr. Springer, I'm going to transfer the ball of power back down to you so that you can move the screen. And your microphone is now enabled, sir.
Thank you. Get that picture off the screen quickly here. So I'm talking about radiant cooling and incidentally heating for residential and commercial buildings. And moving right along. When we do ASHRAE presentations, we're asked to provide our learning objectives. And I guess the idea is to make sure that the presenters stay on track and provide information that's useful to the listeners. So these are my learning objectives, and my disclaimer is that all that you hear here may not be useful. But we tend to cover applications and limitations through through presenting a whole bunch of projects that we've completed and lessons learned from those projects. After that, I'll talk a bit about design considerations and methods, and also discuss what equipment is available and a little bit about controls. And the focus here, again, will be residential and small commercial. So, why do radiant cooling? Well, if you're doing radiant heating anyway, and a building needs cooling, it makes a lot more sense to use the system that's already installed, radiant panels that are installed for providing cooling as well as heating. There's no ducts, so you're eliminating air leakage and convection loss that are normally associated with ducts, which can lose as much as 40% of their efficiency through leakage and thermal losses. You conserve space. You don't have to provide space for ducting, which provides some architectural freedom. You don't have filters to change. And the other thing that hydronic systems offer is the ability to provide thermal storage. And I know my own house, I'm on a time of use rate, so my utility bills are lower in the off-peak periods than they are in the summer on-peak periods. And I can use my system to store energy and stay off-peak. And there are other utility-offered demand response incentives in some locations. And finally, running off-peak can help improve the EER. So this is a list of the projects we're going to go through a tour of. And these are projects that we've done over a number of years. And I won't belabor that anymore. My first exposure to Radiant was this solar home that we built in 1974, and Radiant made the most sense for distribution here because the lower the water temperature for heating, the higher the efficiency of the panels. And for cooling, this house simply had lots of ventilation, a lot of windows to open for ventilation. The system is very simple. It's freeze-tolerant solar collectors that thermosiphon to a storage tank located in the attic. And there's an inner tank within that tank that provides preheated water for a gas water heater. And to prevent overheating in the summer, we use the roof overhang above the collectors to partially shade the panels. And there's a single pump that just circulates water from that tank down through the slab on a call from the thermostat. Very simple system. By the way, if anyone has questions while I'm talking here, please feel free to interrupt. I'm happy to answer questions as we go along. After we got into this solar business and radiant business, we started looking at lower cost materials for radiant floor heating and started using polybutylene, which was being used by the mobile home manufacturers here locally for hot and cold water plumbing. And so we tried that out in some homes, and a production builder, Tandem Properties, approached us and said, you know, can we use this in our production homes? And so they ate up quite a bit of that tubing, and after a while we were approached by gentleman, Scott Elstad, with Shell Chemical, who manufactured at the time the polybutylene resin. And he said, you know, this is a great idea. Can you round up some more manufacturers and for sponsors and take this on the road and teach this across the U.S.? So that's what my partner Dick Bourne and I did between about 84 and 89. And as sort of the outcome of that was the formation of an organization we called the Hydronic Radiant Heating Association, and Larry Drake with In-Floor Heating was on our board of directors, and that organization kind of folded. Larry took over and formed Radiant Panel Association, which the rest is history.
And that's amazing by itself. Thank you very much for having done that, because if you didn't, I would not have a job right now.
You're quite welcome. I don't think I take credit for that. So one of the early projects we did with Radiant, actually the first radiant cooling project we did, was an office building for the Freedom from Hunger Foundation, located in Davis. And we had two 5-ton condensing units that were tied to a couple of carrier heat exchangers. They used to make a packaged heat exchanger for converting essentially a condensing unit into a chiller. And for water heating, we had a condensing water heater, a hydropulse unit, which it was very noisy. And the heat exchanger, the carrier heat exchanger, has it's a kind of a coaxial heat exchanger coil, and the way we mounted it on the wall, or the way it was mounted, was with the connections facing upward. And what happened over a period of time is condensate dripped down the lines into the double wall of the heat exchanger, and each time the cooling system would cycle, it would freeze that water until what you see in that upper photo there is a fairly open channel, and the lower picture you can see how much the frozen water pinched that inner tube off to the point where there was absolutely no flow. So that was one lesson learned on this project, and that you really have to be careful about protecting heat exchangers from freezing. And another lesson was that when you have a larger, more complex system, you really need a dedicated plant manager to oversee and operate the system and make sure everything is moving, running smoothly. Our next commercial project was West Davis Fire Station, and it was a similar project design where we used a couple of condensing units coupled to the carrier heat exchangers. And for supplemental cooling, we had our first example of night ventilation cooling. It was an automated system that brings in nighttime air for cooling. And the biggest lesson we learned on that is that you never use vinyl floor covering or anything but tile over a cooled slab. What occurred was, even though we had a vapor barrier under the slab, the vinyl floor covering acted as a vapor barrier, and there was enough moisture coming up from the soil to collect under that vinyl. And one day we got a call and they said, hey, you've got a leak in your radiant system. And we came out and pressure tested it, and there was no problem with it. And we concluded that what happened was this condensation collected and caused mold and lifting of the vinyl. So let that be a lesson.
Does the same thing apply to throw rugs?
You know, with anything that can pass, that moisture can pass through, it's not as much of a problem. But nonetheless, if that throw rug insulates the top surface of the slab, that allows the slab surface to get colder and approach the dew point temperature of the air. And so if you're running your slab much below dew point, it's going to absorb moisture, collect moisture, and you'll have a soggy carpet. Good question. So this project, this Employment Development Department building in Los Angeles is kind of an example of how you can use other sources of chilled water besides mechanical chillers to keep buildings cool. This building had a conventional system, but on the roof we had an array of sprinklers. And at night, we would pump water from a 10,000-gallon tank and spray it over the roof surface, and that water would reject heat by both evaporation and radiation about equally. And then we would use that water to run through the slab during the daytime. And on the milder days, it had no trouble at all keeping keeping the building comfortable without using any mechanical cooling. But again, the lesson here was that it was a somewhat complicated system. There's, dirt that gets washed off the roof and collected in a filter that has to be backwashed. And if you don't have somebody, a dedicated person maintaining that system, it's going to go down. And I haven't heard anything about this project in many years, but I suspect it's probably not operating still in the way we designed it.
So this is basically a night sky re-radiation cooling system.
Well, a combination of night sky and radiation and evaporative cooling. And as I say, it's about 50%, of the cooling is from radiation, half is from evaporation. And, people have used cooling towers for sort of, water-side economizers before, and there's no reason why they can't be used with radiant systems too, if you have low enough wet bulb temperatures to get the water temperature down.
Have you ever had any experience with any of those roof pond cooling systems like they have up there at Techmar?
I don't know about Techmar's systems, but we've done this with a roof pond where the water is actually, the roof is filled with about 3 inches of water continuously, and insulation is floated on top, and then water is sprayed over the top of that. That was our very first night sky system was done that way, where the roof was concrete, and it just conducted the cooling directly through the roof.
How well did that work?
It worked very well, considering that this is a warehouse, and the surface temperature of the underside of the roof before we started was over 90 degrees. So they effectively had radiant heating going on, and after we were done, we were seeing temperatures below 70.
Interesting. More than one way to skin a cat.
Yeah. So next project, this was like what I call our first successful residential example of radiant floor cooling, and successful because it's been operating ever since when it got installed. We did have a failure. The original unit was a York 2-speed air conditioner connected to a plate heat exchanger, kind of a fabricated chiller. And that heat exchanger failed due to a pump failure. And the pump, stopped circulating. The air conditioner kept operating, and it froze the plate heat exchanger and kind of blew it up like a balloon. And so the York was toasted at that point, so we replaced that with what I call the Ferrari of heat pumps, which is this air mech system you see in the picture, and that is connected to the system using the close coupled T approach, so we're able to maintain flow through the air mech, full flow through the air mech system using its internal pump, so it's injecting chilled water into the radiant loop. So as zones close off, we don't restrict the flow at all through the heat pump. So back to the lesson learned on that, always protect the evaporator with a flow switch. So if the pump fails or anything else goes wrong and you lose flow, it's shutting off the chiller.
Have you found a dependable flow switch?
Well, McDonnell Miller seems to work pretty well, and I haven't had much experience with others. What's your experience on that, Mark?
I have yet to find one. That's why I asked you.
Oh, okay. Yeah, no, it's worked for many years out there. So
Have you considered going to a pressure differential switch to see if it worked any better than the conventional flow switch did? And they have about the same issues.
Yeah. So this project is our house, built 16 years ago in Winters, California, and we took some of the lessons learned. It's always best, of course, to make your mistakes on somebody else's house first. So we took a lot of the lessons learned there and incorporated it here, and have had no trouble. Typical problems of zone valves failing and pumps failing, but by and large, it's been operating very reliably. And the way we operate the system here is there's 4 zones. 3 of them are radiant floor, and 1 is a fan coil. And the fan coil serves just the upper floor. It's a fairly open floor plan, so it also cools some of the downstairs air as well. But mainly for slab cooling, we run the system in the nighttime hours or early morning hours to chill the slab so that we can coast through the afternoon without having to operate the air conditioner. And we're on a time of use rate, so we pay a lot less in the morning hours than we do in the afternoon hours when it's on peak rates. And that our solar collectors up there on the roof, solar panels that are shaded by the tree, help that situation a lot too. So our bills, we pay around $300 a year for electricity, including operating a full pump.
It's reasonable.
We also have a ventilation cooling system there that helps keep the house cool. We were commissioned by, PG&E, or rather Southern California Edison, and the Building America program to do this project in Borrego Springs. There were 4 houses built. Each of the houses had different kind of construction. There was a concrete panel construction. There was a SIP built house, and the other 2 were frame construction using different techniques. And each house had a little different mechanical system. So we had, on some of the houses, we had evaporative coolers, and we had radiant cooling. We had an evaporative condenser, and anyway, lots of different system types. And we worked with NREL to monitor the houses carefully to assess how they perform. And this particular house pictured just had a fan coil and radiant floor with a conventional carrier condensing unit serving a plate heat exchanger. And the climate down there is interesting. It gets very, very hot, over 110 in the summertime. And then towards the end of the summer, July, August, you get a monsoon condition where the humidity starts building up and it gets very, very moist. So you need a way to dehumidify as well as to cool, and that's the purpose of the fan coil that we installed here. And this project is about 200 miles, it's about 2 hours northeast of San Diego. So we had to make sure that we had all of our ducks in a row before we went to the site, which is why we assembled this hydronics module before and tested that in our shop before we took it out there to install it. And for both water heating and space heating, we used a Renai tankless water heater that provided space heating through another plate heat exchanger.
Thank you for that.
And it's not a fun climate to work in if you're there in the summer. This is another Building America project. Michael, the owner, approached us in
Mr. Ginsburg.
Michael Ginsburg approached us in about 2010, I think it was, and said, "I want to do an energy efficient house. Can you help me with the design?" And so the timing was good, and we helped him select air-to-water heat pump that is used for cooling and heating his slab. And in this case, it's an Aqua Products unit, and Aqua Products takes more or less conventional heat pump and parks it on top of a heat exchanger module that includes controls. And so it's fairly plug-and-play system. Because of, again, the monsoon climate, we added a fan coil, put it in series with the radiant floor, so the chilled water would go through the fan coil first before going to the floor, so it wouldn't be overcooling the floor and still be able to do some dehumidification. The wonderful thing we found there was that we could run the heat pump overnight and avoid those really hot daytime temperatures which drag down the performance of the heat pump. And by doing so, we were able to see EERs of over 14, 15 out of a 13 SEER heat pump, which is kind of unheard of in that climate. So worked very well. There was enough storage in the slab to maintain comfort during the day. And what we should have done there was made the chiller a little bit larger, or changed the strategy for delivering chilled water to the fan coil, because we found that on the really hot, humid days, the slab would suck up all of the cooling and result in too high a water temperature through the fan coil to provide effective dehumidification. So we had to work with the owner, with Michael, to shut off some of the zones part of the day so that it would have a chance to dehumidify.
Have you had any experience with some of the different methods of dehumidification that they use? I'm thinking of some of the recovery wheel systems that are out there, the self-regenerating, heck am I trying to call
like descant wheels.
Descant
yeah.
wheels, yeah.
Yeah, no, we haven't played with those very much. You know, they when they absorb moisture, they also give off heat. So you have to. It's kind of like any other dehumidifier. You're paying the penalty of adding sensible heat while you're removing moisture. So and they are kind of expensive. They're maybe more appropriate for commercial applications, but I haven't seen them used in residential applications.
Interesting.
So this next project is it's a residence for autistic adults located in Sonoma, California. And this was a project we worked with PG&E on. It was a zero net energy demonstration. They had a lot of PV panels installed on the roof. And each building, each 3,250 square foot building had its own pair of Altherma heat pumps. And our job was to review the design and to monitor the system to see how close to zero net energy they got. And through our design review, we found that the system was way over-engineered, that the engineer had put actually a pump in series with the pump installed in the Altherma that caused the Altherma to trip off on high flow. And so we were able to work with them to get, the system simplified a bit. We tried to get them to use variable speed pumps that would respond to different pressures as the number of zones ramped down, so they wouldn't be nearly deadheading the pumps, but we weren't successful there. But that's something they could have and should have done. In this case, the Daikin also is providing water heating as well as heating and cooling. And the project, our monitoring data showed that if they had installed the same area of solar panels that they had originally specified, that they would have met their zero net energy goal. So it's still a pretty successful project.
I'm betting the tenants of the building probably enjoyed the silent comfort too.
That's right. Yeah, the folks that have autism are very, very sensitive to sound, to noise, and so this was a real asset for that kind of application, to have a system that no one's even aware it's operating, providing comfort. Another thing on that project, the controls contractor, it was, a building automation control that wasn't very well commissioned, and that was kind of another lesson learned on that project, where we had to work closely with them to correct a lot of problems, operational problems that we were seeing in the monitoring data that they were unaware of. This next project, Honda Motors commissioned this house to be built in Davis on the University of California, Davis campus, as kind of a demonstration of how you can do a zero net energy house that also provides enough electricity to charge an electric vehicle. And there are, besides the solar panels on the roof, it has a battery storage area, and they can generate electricity either to the electric vehicle, to the battery storage, or to the house, and so they can, depending upon what the utility needs at that point in time, as far as what their load profile looks like, they can funnel the electricity so that it's going the right place and helping the utility out, as well as keeping the electric bills on the house low. The heating and cooling equipment we used here was just a water-to-water heat pump that we're using for both domestic hot water and space heating and cooling. And in the lower picture there on the left, you see the little box, which is the heat pump. And to the left of that is a triangle tube storage tank. It's a tank within a tank that's worked very nicely for domestic water heating. The heat pump also has a desuperheater, which we found last summer. Through the middle of the summer, the desuperheater was producing enough heat while the system was in air conditioning mode to provide all the domestic hot water that was needed for the house. Where that heat pump gets its heat is, heat or cool, is from these ground loops. And if you are talking about doing a vertical ground loop, typical 200 foot or whatever vertical ground loop, the cost we're seeing is about $14 a foot. So and about 200 feet per ton, so you're talking about $2,800 just for 1 ton of capacity. So several years ago, we came up with this concept of doing a large diameter shallow bore with a coil of tubing in it, and we used it on some projects before this to demonstrate it, but we used it again here. So there are 8 of these ground loops for this house, and 4 of them are fed by gray water from the house to keep the coils wet, and the other 4 are dry. And we're looking at how the operation of those 2 systems compare. And so far, that's looking promising, and we're just getting a project started that's funded by the California Energy Commission to develop sort of a model for that engineers can use for properly sizing these systems in different design configurations and soil conditions. And I was just going to say the cost is a fraction, a small fraction, maybe a fifth or a sixth of the cost of a conventional ground loop. It only takes them about 15 minutes to drill one of these holes.
Yeah, that sink source is the biggest cost issue with water source heat pumps in those situations. What size of tubing are you using in that vertical borehole?
That one was ½ inch, and I think we've determined that we're going to switch to 3/4 in the future. We'll be looking at it more closely, but we're getting a bit too much resistance to flow through the ½ inch tubing.
It would be interesting to see would be the difference in copper versus plastic.
Yeah, in terms of the heat transfer, yeah, right. It would be. I don't think we're going to try that. I think copper is pretty expensive. So to get the heating and cooling into this building, we've got both a radiant slab with this product that you can just snap the tubing into with insulation on the back, and for this The upper floor, we're using XLAP radiant ceiling panels that are just sheet metal with a embossed groove in them, and the tubing snaps into that after, very similar to what you showed at the beginning, Mark. Mm-hmm. We're, having some interesting dilemmas with zoning on this. We're using the slab as kind of our buffer tank here because there wasn't room for a buffer tank, and so anytime that the second floor calls for cooling or heating, the slab gets it too, and so we're seeing some problems there. We're going to look at maybe making some changes and continuing work on that house.
Are you installing the tubing at a higher density for radiant cooling than you are for radiant heating?
Yeah, generally we recommend that. Yeah, I mean, if you partly for increased flow and partly for maintaining more even surface temperatures on a slab. Yeah, because you don't have as much margin to play with cooling as you have with heating. With heating, you can always ramp up the water temperature. With cooling, you're limited because of dew point conditions and capacity of the equipment to cool. So it's important to get as much out of the design as you can by using narrow tube spacings and high flows.
Cool, literally.
Thanks. So this next project is strictly radiant ceiling cooling. This is a research house sponsored by PG&E that is being done in support of development of energy codes for California. There were actually 4 houses in Stockton that are being leased, and 3 of the houses are testing mini-split heat pumps from different manufacturers to look at their true performance. And this 4th house has radiant ceiling panels. It's a 2-story with panels at both first and second floor. And what you see in the lower photo is a reference heat pump air handler. So literally on this house, the ducts are in conditioned space. They're just the air handler is hung from the ceiling, and the ducts are suspended and routed up the staircase and into the upper floor, and everything's inside the house. And the houses were, super insulated, and their performance was really improved before this equipment was installed. So there isn't too large of a load. Here we're using an Altherma heat pump again for producing hot and chilled water. We've been through one season of cooling last summer, and got most of the past winter season captured with monitoring data. That upper, sort of the middle picture you see of the data logger, lots and lots of wires. There's a lot of sensors in these houses. We're measuring we have infrared sensors pointed at the ceiling panels so you can see what temperature, the surface temperature is. Each room has its own flow meter and temperature sensor so that we know exactly how many BTUs are going to each room. We have 2 types of ceiling panels. The one on the left in the infrared picture there is XLAP again. The one on the right is Masana, an Italian product. And with the Masana, you see it's smaller tube, closer spacing, a little higher average temperature. So, go ahead.
The question I was going to have for you is the ductwork that we see there, I assume that's temporary, or is that the permanent way that they're going to leave it?
Well, these houses are unoccupied, and they're sort of emulating occupancy by they have electric resistance heaters in the houses that are on a schedule to emulate people, and they also have humidifiers to emulate cooking moisture and from people. So when the lease is up, all this is going to be torn out and they'll be put up for sale, I assume.
So they're looking at 500 BTUs per person per hour, and 350 that is sensible and the balance is latent?
That's right. Yeah.
Interesting.
So the fact that they are pumping moisture into these houses means that we have to be concerned with moisture, humidity, and condensation. And we found in the first summer of operation that the upstairs wasn't getting cool enough, and the downstairs was getting too cool. And so far, well, at that time it wasn't zoned, so we had the whole system operating at the same time, and so we found that we had to lower the water temperature from 11C down to 9C in order to get enough capacity out of the ceiling panel so that we could maintain comfort upstairs, but that still left us with a problem downstairs. And it also meant that we were dangerously close to dew point conditions, and so we added a dehumidifier, which consequently introduced a lot of heat to the house that had to be removed, lots of sensible heat. So we're looking at just doing a little fan coil that's tied into the chill water system for dehumidification this coming summer, to see how that works. Let's see. So the most recent project we're involved in was design of this residential building. It's about 2,000 square feet out in the countryside near Winters. There we used an AirMech heat pump for both slab heating and cooling. Water heating was separate. And we provided a fan coil, again, for moisture control, and the owner also wanted a forced air system. So there's minimal duct work here, and the ducts are all in conditioned space, but if the need arises, they have that to use for moisture control as well as just fast response cooling or heating. And what we use for controls here, what we've struggled with in the past is finding controls that are kind of off the shelf that can do both heating and cooling and manage the heat pump operation, zoning, and all that. And we've settled on the Tecmar 406 is pretty much the best alternative as far as that goes. And the nice thing about the AirMech is that it has you can get it with internal storage in a pump. And so you don't have to worry about, it's not variable speed, but that buffer tank that's internal prevents short cycling. And but if the flow is restricted to the heat pump in any way, it won't operate. So we found that we had to do this kind of primary, secondary hydraulic separation approach in order to maintain the flow through the AirMech and keep the system happy.
Maybe I should ask them that flow switch question, huh?
Yeah.
Probably a Colefi.
Yeah, it could be. So that valve that you see in the crossover in the upper part of the schematic is simply there for purging the system. So that's normally kept open so that the AirMech can inject chilled water or hot water into the loop.
So that is part of actually your primary loop then, where that crossover is, would be the primary loop for the AirMech.
Correct.
And
correct.
The downside of that would be the secondary side.
Yeah, and it really simplifies things using a product like the AirMech, because all of the hydronic components, the expansion tank, the pump, the pressure relief, and all that stuff, and all the controls are packaged, so it's really nice plug and play situation.
Mechanical room in a box, as Robert Bean says.
Yeah, that's right. And you just have to be able to read Italian to make it work.
I have a daughter that can do that.
Oh, good. So, talking about design considerations, I talked about floor coverings that you don't want to use, and you can use a combination of floor and ceiling panels or wall panels. Insulation is really critical. We used to think, that you didn't need insulation under a heated slab, but we've measured soil temperatures below the slab and learned that, yes, you really want insulation, even in fairly mild climates below the slab, both for faster response and for reducing the amount of heat that's being lost downward. And of course, slab edge insulation is really important also, is more important. It's important to maintain flow rates and watch water temperatures, design the system for the correct water temperatures, and make sure that panel surface temperatures don't fall below dew point. And I'll show some examples of different hot and chilled water sources here and controls. So watch out for dew points. They're devilish little critters. What this graph shows is the relative indoor relative humidity, and each of the curves, the colored curves, represent a different indoor sort of thermostat set point or temperature. So use an example, if we said we had a 60-degree indoor relative humidity and a 78-degree indoor temperature, our floor temperature is going to be pretty close to 68, which is the minimum recommended temperature for cooling. And also, it's going to be right at, close to the dew point temperature. So it's a good idea. You want to stay below that line. Anything above that line, you're going to be condensing moisture on the surface of the floor or the ceiling panel. For design, the strategy we use is start with room-by-room load calculations using manual J or something similar. And with manual J, you can ignore ducts because, of course, there's no ducts in the system. Also, you can generally ignore latent loads, although in humid climates, you do need to pay attention to that. But you don't necessarily have to size for it because sometimes, like in the Southwest where you have monsoon conditions, the times when the latent loads are the highest are not the times when the sensible loads are the highest. So you can generally size just for sensible loads. And the next step is to pick the greater of the heating cooling loads for each space and use those for the design of the piping system. And designed for, we used to use 15 degrees for heating, delta T, but for cooling, you definitely want to design for 10 degrees or lower because, again, you don't have that much margin to work with and you want to get the most out of the system that you can. So I've got a little flow formula here that just shows the load in BTUs per hour divided by 500 times that 10 degree delta T gives you what the flow rate should be. And then you want to estimate the panel cooling capacity. And for floors, for cooling, you want to assume not more than 15 BTUs per square foot and use as much of the floor surface as possible. An exception to this, there was Peter Simmons, who was an engineer, worked on this Bangkok airport project, and it was his presentation on this was really enlightening and shows that in a situation where you have a lot of solar gain on a floor, that you can go much, much higher than that 15. And in that example, I think they're getting close to 40 BTUs per square foot of cooling capacity because they have sunlight directly hitting this floor. And so they still have to maintain, of course, a floor temperature that's above 68, but they can get a lot more capacity than you would get with a typical residential building. For ceiling panels and wall panels, it's a little tougher because you have to use the panel characteristic performance coefficient to estimate how much capacity you have, and the capacity varies a lot with what that panel is seeing. So if you have a room with a lot of glazing, or poorly insulated room or something with a lot of exterior walls, that panel is going to see a lot higher temperatures than a room that has no windows and is well insulated, and so the effective performance is going to be quite different. And we're using that Stockton work to try to identify what the range of this characteristic performance coefficient is under different conditions, at least that we're seeing in that house. And that part of what will come out of that work is a best practices guide for design of radiant sealing systems. And so here you see the equation for that you can use for calculating the effective heat flux of BTUs per square foot of panel area based on this coefficient and the difference between the mean water temperature and the room operative temperature. So, the mean water temperature is going to be half of what you're feeding into the panel plus half of what you're feeding out divided by 2, or, well, not divided by 2. Anyway, so if you're designing for a 50-degree mean water temperature, then the entering water temperature is going to be colder, and you have to worry about, insulating that pipe well so that if it's below dew point, you're not dropping a lot of moisture on the way to that panel. For water temperatures for floors, we're finding 50 to 60 degrees is reasonable for cooling. And the equation that kind of comes out of the ASHRAE handbook is you can calculate the floor surface temperature by taking your design air temperature and adding the heat flux, design heat flux divided by 2, and that comes pretty close. And for ceilings, you don't want to go much lower than 50 degrees unless you have humidity control with a dehumidifier or a coil, dehumidifying coil. For controls and zoning, as I mentioned, there aren't too many controls that are available to do both heating and cooling. And the two issues that you have is, one, you don't want to have one zone calling for heating and one zone calling for cooling. So you have to have a control that can prioritize and, ask the question, if I have some, 3 zones calling for cooling and 1 for heating, maybe I should be in cooling mode. Anyway, you need something that can make those kind of decisions and to avoid conflicts. And then for systems like more or less conventional heat pump used with a heat exchanger like the Aqua products, you have to deal with heat pump defrost cycles. So what do you do when that heat pump goes into defrost? You don't want necessarily all of that chilled water that's being produced to defrost the heat pump being delivered to one zone, and you want to kind of distribute that throughout the house by opening up all the zones. So it's good to have the control that can do that. And you also want a means of reducing the capacity when fewer than all zones are calling. So that's more of a plumbing issue, and you can use hydraulic separation. If you have a variable speed system, you don't have to worry about a buffer tank. But if you do have a variable speed heat pump, then we found that, for example, with the Altherma, there's enough of a ramp down in capacity that you don't need a buffer tank with that under most circumstances where you have reasonably large zones. So these are the heat pumps and chillers that we're somewhat familiar with. The water-to-water systems, the water furnace is in fairly widespread use. Bosch is the one we used at that Honda house. It's working quite well. For air-to-water, the AirMech, as I talked about, we've had experience with. It's a beautiful unit. SpacePack, we haven't had experience with that yet, but that's one of the AirMech and the SpacePack are the only two that are certified for use in California under the standards, and we're hoping to see that expand. Aqua Products is a lower cost solution, and it works well. You have to pay more attention to controls and provide a buffer tank. The Daikin Altherma, I think Daikin is effectively kind of letting that go off the market in the U.S. They're not adding to their current inventory, and they have a more efficient unit that they're producing for other markets, and hoping to see them bring that back to the U.S. But right now it doesn't look too promising. The Chilltrix is an interesting product that I learned about fairly recently. It's produced in the U.S. Giltrex got into the business, I think, primarily for data center cooling. So, you if you have a data center, they have little heat exchange modules that the boards may be attached to, and they're circulating chilled water to the data center, so they don't have to cool the entire space, and they can control humidity well. But what's most interesting about this system is that they have a module that is designed for humidity control, so they can modulate the water temperature based on what the indoor relative humidity is to provide increased dehumidification as the humidity increases. So there's other products on the market globally, but none others that I'm seeing come into the U.S. yet. At least none that have shown up at the ASHRAE show. So that concludes my presentation. If you have questions, you can contact me at that email address or phone. And I provided links to the products that I've been talking about here. And on the next page, I have some additional reading. There's an interesting article on air-to-water heat pumps in Green Building Advisor. Robert Bean wrote a nice piece on radiant cooling, and he and John Siegenthaler are terrific. If you have any opportunities to tune into any of their presentations, they're both extremely knowledgeable and fun to listen to. And the lower reference here is to a Building America project that we did. It's just talking about radiant cooling as a hot climate strategy for improving the energy efficiency ratio of air conditioners. And it's based on what we learned from that Tucson house, Michael's house. And the final page, I provided some technical references. Again, reference to this top one is a Building America project. Top two are Building America projects that were published in ASHRAE and also through a Building America program. Top three, sorry. And then the granddaddy of radiant cooling is Bjarne Olesen, who has a number of published papers, and this was the first one that he published that I referenced heavily in developing our radiant cooling designs. And then there's a Peter Simmons article there, ASHRAE paper that talks about all his work at UC Berkeley, and with talks about the Bangkok Airport project. So with that, turn it back to you, Mark.
Great. Well, you know what? I would like you to tell us a little bit more about what it is that Davis Energy Group does.
Okay. I'm still trying to figure that out. Right now, we're very heavily involved in developing standards, residential standards for the 2019 Title 24 Energy Code for California, and it's exciting work because the CPUC has kind of dictated that 2019 is the year that all new homes will be, or 2020 is the year that all new homes will be zero net energy in California. So it's a real challenge because the Energy Commission also dictates that this must be done cost effectively. So that's keeping us quite busy right now. We have a number of projects involving building energy monitoring. We're looking at monitoring, for example, what happens when you insulate the underside of a roof deck to create a non-vented, essentially conditioned attic, so that you keep the ducts, minimize duct loss and losses from equipment that goes into the attic. But there's a concern that you can form condensation on the underside of the roof deck, and so we're doing 3 projects actually looking at that. What else?
Do you do consultation? If a contractor were to come to you and say, "Hey, I've got this building that the existing cooling system is inadequate, and I want to consider doing a combination of radiant and air cooling systems," would you be able to help them out?
Yeah, we can. Most of our work here lately has been larger projects. I don't know if you're aware, but in April, we were acquired by Gas Technology Institute, GTI International out of Chicago. And so they're kind of urging us to spend our time on larger projects, which tend to be more productive for us. But I, personally still really enjoy, consulting on smaller projects. And if there's a need, shoot me an email and I'll see what we can do.
We have one member named Harvey Raymer that has been struggling with a church that he has that he's trying to satisfy their needs for cooling and is considering radiant cooling, and has been having trouble trying to find answers to certain questions that he's got, and is always looking for resources. But I'll mention the fact that he may want to talk to you and see if he can hire you as a consultant for this church to make sure he keeps the people on the inside cool and all the equipment working the way that it was supposed to.
And dry, too, because there's going to be a lot of latent loads in that building.
Yeah, there is a lot of transient latent loads in that area.
Yeah.
And that's one of his concerns. He's into HVAC, so he understands. It's not like he's completely new to this whole process, but he's just wanting to make sure that he does the right thing, so he only has to do it once.
Yeah, that's smart.
Well, let me flip back forward again to these slides and show everybody who it is that's going to be our guest for next month. Is a guy by the name of Bob Barmore. He has a company called Thermahex. And what he makes is a modular panel that is I think it's like 16 inches by 16 inches. And they plug these panels together and put them underneath the patio tiling system that's typically used for driveways or swimming pool decks. And they can provide either snow melt, or in the case of swimming pools, they can actually cool the deck and use that heat that they're extracting off the deck to heat the pool. And I hadn't mentioned it to him yet, but I think there's probably a pretty good market in Arizona, Texas, Southern California. We actually use those same panels to do night sky heat rejection to cool the pool down, because there's nothing worse than hopping into a pool that's actually hotter than the outdoor air temperature. It's not very cool, literally. So thank you very much, everybody, for coming in and attending. Let's see, I've got Richard McGrath that has a note in here that Building Science Corporation, the perfect wall. A wall is a roof as a slab, and that's from Joe Steebrook. You probably know Joe, I would think.
Yeah, I know Joe very well. Yeah, he's, we were involved in the Building America program from about 2002 through last year, and Joe was very prominent in that, and I learned a lot from him.
He's a character.
He is a character.
Yeah, I enjoy being around him. He's a fun person to hang out with.
Yeah.
Let me ask one time here real quick, is there anybody here that has a question that they would like me to enable their microphones? If so, put something into the Q&A so that I can enable your mic. And if you have any questions that you would like to ask Mr. Springer, then we'll let you ask him directly and see if he can answer it for you. Don't see anybody coming up with any questions. I'll give you another 10 seconds. The internet's slow. Colin's got a question.
Good.
Mr. Wonder. Colin, you're live.
Yep. No, I just was wanting to thank David for a great presentation. Very informative.
Yeah, thank you, Colin. It's fun work. I've enjoyed the radiant business for a long time, and hope to be able to continue to make contributions.
Well, I see another question. Colin, thank you very much. By the way, Colin sits on our Government Relations Committee. He's the chairman. And Mr. Scotty. Elio.
Yes.
You have a question?
I sent it already.
Oh, you sent it?
Yes.
Oh, there it is down there at the bottom of my screen. Hang on just a second. Let me get it up here. It says, do you know anything about Becca capillary tubes?
I've seen them, and we haven't used them on any projects, but it's kind of, I see it as kind of a site-built approach to the Masona panel. It seems to me that it's somewhat labor-intensive, but actually, I think they were used at a project at Arizona State quite a while back, and for radiant cooling sealing. Yeah, I mean, it seems like a nice product.
Elia, what would you like to tell some of the folks that are listening in here about your product?
I don't know if you can hear me well or not.
Yes, I can.
Well, I was in contact with the Davis Energy Group in 2006, but I never got any response from them back. So it's a different system, and I think it's much simpler. But I want to get Davis Energy Group to say so.
Well, we'll have to find a project for it, which we're working on.
Yes, we're trying for 10 years and no response. I think they should do once at least and get first-time experience, and they can compare with everything else.
Now, we've got an opportunity coming up here for our members real soon with the folks at the Northwest Energy Efficiency Alliance. And they would like to take as many different radiant systems as they possibly can and expose them in small commercial and light commercial applications so that they can get a better feel of what's going on. So I will throw your hat into the ring as a potential contributor of materials, or provider, I should say. They're not looking for contributions. They want people to actually pay for these systems, and see if maybe we can get you out there in the field to show what your system does in comparison to all of the other systems that are currently on the market.
Well, I am sending my email. If somebody wants to talk to me, please contact.
Got it.
And we can take it from there.
Great.
Yeah, thank you, Elio. I apologize for not getting back to you back then. And, you know, we have to just work on projects that we're sponsored to work on. And if, you know, some opportunity comes up in the future, we'll certainly make sure that you're on the list.
And my advantage, I would say we are dominant in Europe for the last 30 years, so I think we got something to offer.
Sure.
Mainly, if it's not invented in the U.S., you know, it doesn't exist. That's my problem.
Yeah, well, that's not quite true because Masana, for example, is an Italian product, and there are you know, we're seeing a lot of European products coming into the U.S. market, and they're all wonderfully engineered, and just have to get better market penetration with them.
We got in the last 10 years, we got few good installations in the U.S., in California, Chicago, Washington, etc. So we are not really unknown, but we are little known.
Yeah.
I think it's probably our fault, but we do the best that we can to get to everybody. Yeah.
Do you have a U.S. representative?
Yes, we are the U.S. representative.
Oh, okay.
www.beccausa.com.
Got it. Okay.
Well, Elio, I would like to extend the offer to you, too, to come in and be on this show and make a presentation. We're always interested in looking at new products and applications, and would be more than willing to allow you to come in and do it. I'm currently booked all the way into August now, but September is open. So if you would like to...
I just send my phone number. If somebody wants to call me anytime, we can chat a little bit.
Sure. Yeah, I've got all your contact information from our membership.
Very
so
good.
I will be in touch, and we'll try to get you onto the show later this fall and see what we can do.
Thank you.
All right. Well, David, it's time for dinner. Thank you very much for your time and presentation. You've done a fantastic job. You're a pioneer in the field, and I want to see the backside of you someday to see if the arrow marks are still there. That's what Larry Drake always used to tell me. He says, you can tell the pioneers because when you roll them over in a ditch, they've got arrows in their back.
Yeah, poor Larry had a lot of arrows. That was a tough job, and I hope it's gotten easier for you.
Well, it isn't. It hasn't. This is the busiest I've ever been in my whole life, which is good because it makes time fly. It's rewarding to have people like you that have been in the industry for a long time that come forward to tell us about trials and tribulations and what to do and what not to do so that we don't make the same mistakes. And, we're all learning from this experience, and it's opening new horizons. When I first got into hydronics 35, 36 years ago, you would have never have convinced me that there was such a thing as radiant cooling. And it has basically taken that dividing line from where it's heating dominated versus cooling dominated, and we're never allowed to go south of that Mason-Dixon line. That's no longer there. So it's great for the manufacturers, it's great for the contractors, and it's fantastic for the end users. If you've never had a chance to experience radiant cooling, if you ever find yourself in downtown Las Vegas, walk into the Crystal Mall. Uponor has a radiant floor cooling system in there, and feel the comfort, and continue walking back and go all the way back to I think it's the Rio, is a casino that's back in the back of that mall, and they have a conventional air-cooled system there. And when you walk in, you're uncomfortably cool. So it gives you a new appreciation of radiant cooling, and we're doing everything within our powers as an industry to try to get more of these experiential centers set up so that people can actually experience radiant cooling, in hopes that we can extend our market and prove to the world something we've known forever, which is we're the most efficient system there is.
Yeah, no, that's right. What Peter Simmons would say is, you want to control humidity in a building anyway, and if you do it properly, then you can do radiant cooling.
Yes, yep, absolutely. There was one thing that I meant to mention to you. I think I told you during our dry run test that I was headed down to talk to the National Hardwood Flooring Association about the issues they've been having with radiant flooring. Are you familiar with any projects that have been done with radiant floor cooling that have hardwood floors on them?
Fortunately not. They would be expert witness cases.
Yeah, don't want to go there. All right, well, that's pretty much what I thought it was. But again, thank you very much for your time, and thank you to our listeners for tuning in. And as soon as we get this show rendered, we'll send it up to the permanent archive for the RPA members only, and we'll catch you all in a flip-flop.
Thank you very much, Mark.
Thank you. Take care.
Thanks, Mark.
Bye-bye.